Johannes. Thank you.
I do, yes. Yeah.
So thanks. That was a fascinating discussion. So I assume you're all quick readers and have bionic eyes. This slide basically says, don't buy shares on the back of this presentation. And I promise you, it is the most worthy slide of my presentation. Ladies and gentlemen, good morning. It's a pleasure to be here at CeBIT today. I'm sure some of you are wondering why one of the world's largest energy companies is talking at one of the largest IT events in the world. And I'm standing here before you because my biggest role is to search for the best and the brightest IT innovations, technologies and companies and integrate them into Shell's operations. The aim is to enable the Shell business to work safer, better and faster. It may surprise you that Shell has a long history of IT innovation. For example, we were involved in the development of random access memory. We hold several patents in this area and have been at the forefront of the high-performance computing industry since its inception. Shell has long recognized that energy and IT industries have a symbiotic relationship, and we can see that relationship is set to become even deeper and broader. Success in the energy industry often means winning the technology race, and IT is an essential part of that. And over the next 30 minutes, I will explain how IT-led innovation and the collaboration at Shell has evolved and its vital importance to the energy industry as a whole. I will touch on some of the trends and themes that we'll cover here this week, and in particular big data and analytics and the Internet of Everything. I will also give some practical examples of how they relate to our day-to-day business. But first, I need to give you a bit of context of the energy challenges the world faces. So we all know energy is vital to our daily lives. By the mid-century, our planet could be home to more than 9 billion people, with 75% living in cities, up from 50% today. And that means adding the equivalent of a city the size of Munich every week for the next 40 years. And more people will enjoy higher living standards, gaining access to hospitals, public transportation and reliable electricity. But these positive developments will place pressure on resources and the environment. Even with the welcome increase in renewable power generation and improvements in energy efficiency, fossil fuels will remain a critical part of our energy landscape for the foreseeable future and will still account for around half of all energy used in 2050. But finding and producing that energy is becoming harder. The era of easy oil and gas, if it ever existed, is over. Now resources are increasingly found in remote locations, such as deep water offshore and complex geologies like shale rock formations. Business as usual will not fill the energy gap or address the environmental stress that could result. There has to be a fundamental shift in the way we think about, produce and use energy. In order to meet the increase in energy demand, gas can be a big part of the solution. So when compared to coal, which is used extensively in electricity production, gas has roughly half the CO2 emissions. It is the cleanest burning fossil fuel. So natural gas is very versatile. It is transportable by either LNG carriers, tankers or pipelines. You can use it for heat, a feedstock for petrochemicals and fertilizers, generating electricity, or as a transport fuel. And Shell already produces more gas than oil and is pioneering new technologies, such as the Prelude floating liquefied natural gas facility. And this will be the world's first floating offshore facility that will produce, liquefy and offload gas directly from the field. So Prelude is still under construction, but when it's complete, it will be the largest floating facility in the world, bigger than a US Nimitz-class aircraft carrier. In fact, 6 times heavier. Game-changing shifts in technology like Prelude required extensive innovation. And it will help to transform the industry and ensure the secure supply of energy the world needs. So Shell is fortunate to be the user of many of the most cutting-edge information technologies and innovations. The size and scope of our business means that our day-to-day work is a roll call of many of the hot topics in the IT industry. Big data and analytics, high-performance computing, mobile, cloud, software as a service are all challenges and opportunities somewhere in my company. So in my opening remarks, I mentioned that the energy industry is part of a technology race. Technical innovation is key to competitiveness and therefore a major focus at Shell. So traditional R&D models meant building everything in-house and protecting your intellectual property to gain advantage. And that model is still important, and you can see some of the technology centers on this map. But it's no longer sufficient in today's world, as we cannot be or have the resources to be an expert in every field. Therefore, we are changing our approach to innovation itself. Specifically, we're focusing more on collaboration and open innovation. And we found that collaboration is a great catalyst for delivering high-quality solutions rapidly. We have a number of routes to innovation. In technology areas where Shell has leading edge and competitive advantage, we develop proprietary solutions in-house. In other areas, we partner with the best and the brightest who have complementary strength. And furthermore, we bring in third-party solutions and integrate them with our own systems where appropriate. So co-innovation is not just about creating products or services to sell to Shell, although we clearly can be a large customer. It is more about mutually creating value. We get first-mover advantage, and our partners get a product or service to market to other energy companies, and even beyond. And I will give some concrete examples of that later. So Shell's IT ecosystem is made up of our leading IT suppliers. We challenge the entire ecosystem to work together on projects to produce differentiating products and services to Shell. And often that requires competitors to work together. So to give you some dimensions, the combined R&D budgets of Shell's top 12 IT suppliers is estimated to exceed $40 billion per year. And if you count all our IT suppliers, it's probably more in the region of $100 billion per year. And this is an example of how we leverage our ecosystem relationships to realize more value, share research and development, and create joint go-to-market solutions. So you can see, Shell has an innovation mindset. But what areas should we focus on, or do we want our partners to focus on, to get the most value? That's one of the biggest challenges of my job. Every 2 to 3 years, we undertake a research exercise to identify emerging IT technologies that are relevant to our business. Recognizing emerging technology trends and the changing needs of our business, we have defined 9 interdependent domains which direct our IT innovation thinking. In particular, we look for disruptive or transformational technologies that have the potential to create significant value or enable new business models. And one of our internal innovation challenges is that the IT industry evolves at an extremely fast pace and looks for short-term returns on their investments. The energy industry, however, works on a considerably longer time frame. The planning and construction of energy infrastructure can take 5 to 10 years, and the actual asset, being an offshore platform or refinery, can operate for many decades. So future-proofing is a vital part of our planning process. And I would challenge anyone to predict what the IT industry will be in, let's say, 30 years from now. So I certainly don't have a crystal ball. Let me first highlight 2 of the domains we are looking into: mobile and unmanned operations. In mobile, we envision field workers utilizing mobile and wearable devices to increase their effectiveness. Provisioning of information via mobile solutions will shorten the loop from data to decisions and minimize health, safety, and environmental risks. Today, we already equip many of our field workers to interact with global experts by voice and video. In the unmanned operations domain, we also see opportunities for improving safety, a top priority for Shell. For example, using unmanned aerial vehicles, like the one you see on the slide, to inspect high structures like a flare stack or chimney is far better than erecting scaffolding and having my colleagues working at height. It also avoids unnecessary shutdowns of production facilities. And in addition, the quality of the data is significantly better. In the future, the focus of unmanned operations may widen to include using fully autonomous aerial vehicles or robots to check hundreds of kilometers of pipelines or the insides of tanks, so we have an accurate picture of our assets. So I don't have time today to go through all the innovation domains in detail. But the point I want you to take away is that they all benefit from our open innovation approach. And we do not need to reinvent the wheel. All we need to know is what's out in the market to make those existing wheels work better for our business. The themes of CeBIT this year demonstrate that other people think that similar things are important. And for the rest of my presentation, I want to highlight a couple more examples where the power of IT and open innovation really makes the difference to Shell. The most successful companies are the ones that understand their customers best. They communicate with them through their preferred channels and provide them with truly relevant product and service offerings. We are investing in technology and business change to deliver real-time, personalized offers to influence buying decisions at the point of purchase. We do this across multiple channels and enable predictive modeling by mining data with advanced analytics. By bringing together several data sources, including internal data about our brands, sales, loyalty card customers, and external data from sources like social media, we will deliver relevant, personal, and context-sensitive offers. It is similar to how a music streaming service introduces you to a new band based on your existing tastes. The customer response drives a further enrichment of the data, and it's a virtuous circle. We are already using this technology to interact with nearly 2 million UK members of the Shell Drivers Club to provide them with targeted products and benefits. Mobile connectivity has brought us closer to our customers, and Shell has created an in-house app factory. We have developed numerous apps for customers and internal clients, including our award-winning Motorist app. In the medium, we see more integration of payment into mobile handsets and vehicles, including our own loyalty programs. We are also closely monitoring operating systems for cars, as we expect to leverage the connected vehicle to provide new, exciting, relevant products and services to our customers. Shell already had products which help fleet owners manage their operations and drivers to reduce their fuel cost, CO2 emissions, and increase safer driving. We see the connected car of the near future as a key enabling technology to deliver new services and products for our customers. These services will become more integrated into the connected vehicle of the next generation. The energy industry is a complex and capital-intensive business. It's critical to have top quartile performance in the development, construction, and operations of our assets, and to be able to react quickly to changes in the market. What's more, often the cheapest and most efficient units of product produced are the extra units you get from running your existing assets optimally. But the real question is, how do you know what the optimum is? In the age of Internet of Everything, turning operational data into better decisions can lead to a huge commercial and competitive advantage. We install sensors in chemical plants, refineries, on offshore platforms, and even on subsea pumps. They produce real-time data streams, enable automated or computer-assisted drilling, and allow assets to be monitored remotely. We have developed a range of smart solutions that compare real-time operational data with predicted performance, so we can identify the right actions in our facilities, often without the need for human intervention. Last year, we opened a remote monitoring and diagnostic center in the Netherlands, from which experienced engineers can review the health and operations of key rotating equipment, like compressors and pumps, across the globe. So specialist engineers provide site diagnostics and services and advice remotely. We call this Smart Connect. Smart Connect has led to an increase of production of nearly 900,000 barrels of oil equivalent last year, through monitoring of more than 2,100 equipment trains. And in refineries like the one shown here, we have proactive technical monitoring, which identifies risks to our reliability. This enables us to plan our maintenance schedule more accurately, increase the length of time between shutdowns, and shorten time taken to the maintenance itself. And this stands reason, because if you know what needs to be done ahead of time, you can have the right tools, expert teams, and spare parts ready to go. Proactive technical monitoring is a new application which has been deployed to 8 refineries, including the major sites of Bukom in Singapore and Pernis in the Netherlands. And these applications run on our Smart Solutions platform, which integrates third-party tools with our own technologies. The opportunity that predictive analytics represents for us is significant, real, and transformative. It has a value potential of hundreds of millions of dollars per annum globally, because it increases production and availability, as well as reliability and safety. To support our smart infrastructure, we have been collaborating with Cisco for several years on a range of co-innovation initiatives in areas like industrial communication and automation. This began with Cisco being a member of our IT ecosystem I spoke about earlier, providing network, video, and compute technologies. And as the relationship evolved, we looked for areas where we could develop first-of-a-kind technologies in which Shell could gain first-mover advantage through early adaptation, while striving for longer-term standard industry solutions. In short, speeding up the innovation to solution lifecycle. A key innovation aspect is ensuring how we fit new technologies in with existing operations. And Cisco has also proven capable of managing alliances with other technology providers and engineering solutions that are interoperable. More recently, we have jointly worked on creating a connectivity and hosting platform to manage security controls and report compliance in the process control domain. We are also exploring new opportunities in the area of Internet of Everything and fog computing. For example, looking at how we can handle and process increasingly large data sets and volumes at the edge of the network. And these are examples where an open innovation mindset has created real value for both companies. So moving on now, I want to focus on high-performance computing and its role as a critical enabler for the oil and gas industry. You'll have seen in movies dramatic scenes of gigantic waves hitting a city. We use high-performance computing to model the potential impact of a large wave hitting an offshore platform with all the forces and physics modeled correctly. It may look less dramatic, but it provides us with vital information on how to best design and safety build structures to stand up to the worst nature can throw at them. On the quantum scale, we use patented techniques to model molecular interaction, which predict how catalysts will react as a chemical reaction unfolds. The great advantage here is that we can run hundreds of computer-simulated experiments to narrow down the most promising catalyst for real-life experimentation in the lab. And that's important because the lab experiment can take days or weeks to complete. However, the main use for high-performance computing at Shell is in the area of upstream exploration and production. Finding and producing resources relies on gathering, visualizing and interpreting vast quantities of seismic data. It's like an MRI of the Earth to build up a picture of the subsurface. And with these images, you can actually plan where you want to drill your wells and how to manage production for the field subsequently. Bear in mind, a single offshore well may cost over $100 million, so you better make sure you're drilling it in the right place. And to explain how difficult it is, consider the following. When Shell discovered the giant Brent fields in the North Sea just over 40 years ago in 140 meters of water, we could only drill during May to August due to severe winter weather conditions. And today, we drill all year round, and in the Gulf of Mexico from drill ships in over 3,000 meters of water. And Shell is drilling the equivalent distance from this hole, twisting and turning to the center of Hanover and hitting a 2 by 2 meter target. That is how accurate we need to be. If drilling a well is a major investment and technical challenge, so is acquiring and interpreting seismic. A single seismic survey can cost tens of millions of dollars and easily produce tens of terabytes of data today. But the pace of change in this area is striking, as new advanced seismic acquisition techniques create ever more data. In the next couple of years, we will go from terabytes to petabytes of data in a single seismic survey. And Shell uses its high-performance computing capacity to process the seismic data and its state-of-the-art visualization and interpretation software Geoscience to accurately locate hydrocarbon deposits. Geoscience enables us to see details of the subsurface that many others cannot see, as shown in the little movie here on the screen. In fact, when we talk about any big success in Shell, exploration success or large production increases, they're all supported by state-of-the-art interpretation software. So the more detailed your seismic data, the better your seismic processing, visualization, interpretation, the more you can de-risk your project. Therefore, there's an insatiable demand for more compute power to process higher density data sets, and all of this at a lower cost. And we found that the best way to meet these demands is to take an integrated approach across both hardware and software. Shell aims to maximize the overall capability by ensuring that our applications take full advantage of the underlying hardware. The technology changes rapidly, so it's important to have a close connection with the key technology developers. For instance, the high-performance computing collaboration between Shell and Intel has generated benefits for both parties. Shell's open innovation approach has enabled Intel to gain a deeper understanding of high-performance computing requirements for the energy industry, resulting in better products. In return, Shell has been able to take full advantage of the latest technologies and also anticipate future developments. For example, this has enabled us to more effectively address seismic data processing requirements by faster deploying Intel technology and gaining first-mover advantage. What I've tried to do today is give you a sense of the richness and diverse ways in which the energy industry is intertwined with the IT industry. However, none of this can be made possible without the right talent to take us along our journey and actually deploy and create value from the good ideas we see all around us. People thrive when given the freedom to express their professional passion and demonstrate their individual creativity. So each year, Shell is looking for the best and the brightest to work on the areas I've mentioned today. So in conclusion, it's worth remembering that energy demand will double by the middle of the century. Consequently, the world faces a tremendous challenge in how to find, produce, and use that energy in an environmentally acceptable way. Information technology will be an important enabler for meeting the future energy demand. Open innovation will be key in developing the next generation of IT solutions for our industry, as it allows us to work with the best and the brightest. So our message to the IT industry is, come, work with us. Let's innovate together. Because at the end of the day, a lot of bites go into a barrel. Thank you for your time today. I hope you'll all have a successful conference.